3D printing is a relatively new technology, and there's been loads of advancements within the past few years. It's become cheaper and more readily available throughout the world, which allows for more 3D printing to be used in less economically developed countries. The basic background into 3D printing is that you design what you want to make on a computer-aided design program. This is then printed on the 3D printer, which uses plastic filaments. Plastic filaments can vary, and it depends on what you want to make and which filament you want to use. Some start quite cheap, and they range up to more expensive ones that are generally stronger. The first interesting point when it comes to 3D printing is that you can now 3D print housing. This allows for the poorer countries in Asia and Africa to have access to housing for as little as $4,000, and this will take up to 24 hours to print, which is relatively quick, and the labour isn't much at all. To produce these houses, layers of concrete are used rather than the plastic filaments that would normally be used in 3D printing by hobbyists. However, one drawback of this is that they need the access to these larger 3D printers to begin with. There are multiple uses for the medicine industry, which include using prosthetics. These can be customized as they can be designed and then made in order to fit the patient. One problem with this, however, is that it can be expensive, as you need to use a stronger filament in order to pass the grade that's required. Injection molded plastic is the more common choice here, as they are stronger and more durable, which means that 3D printing has some work to do in order to catch up and become more readily available. A large amount of 3D printing in the medicine industry is to create organs. These organs are not only for patients, but also can be used for trainee surgeons. This allows them to look at and cut up the 3D printed organs, which is a fraction of the cost of real organs. A common use of 3D printing is with designers and also hobbyists. A strong positive for designers is that they're able to quickly prototype things and change the design and re-prototype it again. This allows for them to produce multiple prototypes in a day if they want to. 3D printing is also very accessible, and it's quite entry level for those who want to start 3D printing as a hobby. The printers can start at as little as £150 nowadays, and the filaments are also quite cheap. The only restriction with how complex an object you'll make with 3D printing is your design. If you can design something that complex, it can be printed just as easily. This allows 3D printing to be used across the spectrum, from just beginners all the way up to elite level users who can design anything within 10 minutes. One drawback about design can be that you can infringe copyright laws. Basically, a designer can just copy a company's product, and this leads to all sorts of copyright infringement. Cheaper 3D printers also have their drawbacks. The quality of finish isn't as great as with higher end printers. You can normally see the layer of filaments as they are printed. To get a higher quality finish, you would require a more expensive printer, which aren't as readily available. However, with the more expensive printers, you can create a factory finish. For example, Adidas uses the higher quality printers for its 4D midsole on their shoes. The layers of filament can't really be distinguished, so the product looks more aesthetically pleasing. The midsole is formed using a digital light synthesis technique. Oxygen and light is used to create it, and it pulls the sole from a liquid and forms a 3D printed model. This technology also makes a higher quality print faster than traditional 3D printing. This also links in with our next point. Printing is also time consuming and can need attending to when something inevitably goes wrong. In the upcoming video, Joseph DeSimone talks about the possibilities of 3D printing if it was 3 times faster. The potential capabilities, if this were to be true, is limitless, as you'll see from the video.
And so the opportunity now, if you actually make a part that has the properties to be a final part, and you do it in game-changing speeds, you can actually transform manufacturing. Right now in manufacturing, what happens is there's so-called digital thread. In digital manufacturing, we go from a CAD drawing, a design, to a prototype to manufacturing. Often the digital thread is broken right at prototyping, because you can't go all the way to manufacturing because most parts don't have the properties to be a final part. We now can connect the digital thread all the way from design to prototyping to manufacturing. Right? And that opportunity really opens up all sorts of things, from better fuel efficient cars, dealing with great lattice properties with high strength to weight ratio, new turbine blades, all sorts of wonderful things. Think about if you need a stent in an emergency situation, instead of the doctor, she pulling off a stent out of the shelf that was just standard sizes. Having a stent that's designed for you, for your own anatomy, with your own tributaries, printed in an emergency situation in real time out of the properties such that the stent could go away after 18 months. Really game-changing. or digital dentistry and making these kinds of structures, even while you're in the dentist chair.
On the whole, I think 3D printing is going to be a part of our lives for a long time. We've only just begun to see the possibilities, and it's only going to get cheaper and more available worldwide from here. The surface of the possibilities of 3D printing hasn't even been scratched yet. There's so many pathways that this can take, and the jobs and careers that we'll probably be using in 5 to 10 years, they'll probably revolve around 3D printing. The cheaper 3D printing gets, the more available it's going to be for housing in less economically developed countries, as well as the medicine industry. Schools are going to be able to buy these cheaper 3D printers, and they can be used across the curriculum in design and technology, maths, and students can be pushed into these avenues. The 3D printing can be used as part of STEM activities, which can broaden pupils' horizons with regard to science, maths, and technology. Overall, I think 3D printing is heading in the right direction, and within 5 to 10 years, I think most people are going to have 3D printers in their homes, just like the computer.